this video, we will be looking at various quadratic application problems using more than just the graph. So we're going to try to find key information in a more algebraic way using our skills of factoring, expanding, and knowing all of the properties like how to find the zeros and how to find the y-intercept. So first we'll start with a little reminder that the zeros come from the factored form, which is when you have your two brackets, and the y-intercept comes from standard form where you don't have any brackets and things have been expanded and simplified. So let's start with our first example. The trajectory of a model rocket can be modeled by the relation h equals -5t squared plus 100t, where h is the height of the model rocket in meters and t is the time in seconds. We're going to answer each of these questions using the graph and then also relating it to the equation, because the goal of this lesson is to be able to answer various types of questions without the graph. So let's start with the first one. What is the initial height of the rocket? So if I look at the graph here, well, at time 0, the height is 0 meters. And this is our y-intercept. And we know that the y-intercept comes from the constant in standard form. If we look at our equation, there is no constant. So first of all, I will write my answer of 0 meters, but relating it to the equation, here is the standard form. And I know some people, if there is no constant, they like to write the plus 0, and there's the initial value. So anytime you see the word initial or start or beginning, that's going to be your clue that we need the y-intercept. So there we are. No calculations needed here. What is the height of the model rocket after 4 seconds? Now we've done questions like this, but if we look at the graph, here's the time 4 seconds. I'm going to go up to see where I reach my parabola, which is roughly here. And then I'll move across to predict the height. And it looks like it might be maybe 320 meters. So I'll make my prediction here around 320 meters. And that's from the graph. But let's actually find the exact height, and we're going to use the equation. If I'm giving you 4 seconds, this 4 seconds is the time. So let's just replace t with 4, and then we're just going to simplify it. So h equals -5, and then instead of t squared, we're going to write 4 squared, because we're trying to find time of 4 seconds, plus 100 times 4. And thinking about bed mass here, we are going to do our exponent portion first, just like we always did in table of values. So 4 squared is 16, and the rest I will leave as is. Next, we will do the multiplication, so this portion and this portion. So -5 times 16 is -80, and 100 times 4 is 400. And if we actually simplify this, my prediction was correct by chance, and it actually is 320 meters. So I will write a little therefore statement here. Therefore, after 4 seconds, the rocket is 320 meters high. So for this type of question where I give you the time, it's just a little bit of a substitution. And we've done this in the past. Okay, for C, when does the rocket land? Okay, if I look at my actual graph, I'll go in green here. Well, this is when the rocket took off, and then it's going upwards, it hits this maximum, and then it starts to come down. It's coming down, and eventually it hits the ground right here at 20 seconds. Now this is a 0. It's an x-intercept. So anytime I'm asking about a landing time, a height of 0, something related to 0, we're looking for our zeros or our x-intercepts. And we know that zeros come from factored form. So we have to factor. So if I look at my equation, h equals negative 5t squared plus 100t, we know that our first question for factoring should always be about a greatest common factor. And looking at these two terms, they both have a t in common. The first term is negative, so I know I have to take out a negative, and they're also both divisible by 5. So negative 5t is your greatest common factor. So that's what I'm dividing out. So negative 5t, and then what I'm left with is negative 5t squared divided by negative 5t is 1t, and then 100 divided by negative 5 is negative 20, and the t's cancel out. And now, if I'm trying to find my zeros, we know that we always just take the opposite sign of what's inside the bracket. So in this bracket, well, it would be 20, and that's exactly what we predicted from the graph. From this bracket, remember, whenever it's just a common factor of the variable, the 0 is just 0, because technically I could write it as t plus or minus 0, and that's how you get that x-intercept. So here it is. Therefore, the rocket lands after 20 seconds. And there it is. All right, let's try another example, and this time I am completely taking away the graph, and we're going to try to use these connections. So the initial value is the y-intercept. Landing time, or your height being 0, that's your zeros or your x-intercepts. And if I just give you a random value for time, we're just plugging it into the equation and doing a mini substitution. So a water balloon is thrown up from the top of a building and can be represented by the equation h equals negative t squared plus 2t plus 8, where h is the height above the ground and t is the time in seconds. What is the height of the building? So that's asking you for the starting height, or the initial height. And we know that means y-intercept. And because I'm giving you the equation in standard form, well, here's our y-intercept right there, 8 meters. Okay, now one little thing I like to do is drawing a sketch for myself. If I know that the y-intercept is 8, I know I'm going to have time here, and I'm going to have height here. The y-intercept is 8, and just thinking about how something might be thrown, it's thrown upwards, and then because of gravity, it comes back down. Now, there's no accuracy to this, but at least I have a little visual to guide me through. All right, what is the height of the balloon after 1 second? Now, obviously, looking at this sketch, I have no idea at 1 second what the height is because there is no accuracy here. But that's not a problem. If you're given time, let's just replace time with 1. And then you can go straight to your calculator, or you can do some BEDMAS, whatever works for you. So h equals negative, and then instead of t squared, I'm going to write 1 squared, and make sure you put whatever the time is in brackets just to be safe, plus 2 times 1, and then plus 8. So again, thinking of BEDMAS, exponents come first, so I'm going to do this 1 squared, which is just 1. And 2 times 1 is also just 2, so I'm just going to clean that up because the 1 doesn't do much. And then once I've done that, now I just simplify this. Negative 1 plus 2 is 1, and then plus 8 is 9. And you can just plug that all in at once in your calculator. So that means after 1 second, the height of the balloon is 9 meters. So after 1 second, the balloon is 9 meters high. And visually that makes sense. Even though my graph wasn't the most accurate thing, it makes sense here. So when does the balloon hit the ground? Well, hitting the ground would mean I want this value right here, which is a 0. So let's factor. I'm just going to write the original question. And our first question is there a greatest common factor? Because this right now, although it's a trinomial, it's not a simple trinomial because of this negative. We need to get rid of it. And remember, it's a -1. So let's do a greatest common factor of -1. And then -1 divided by -1 is +1. So we just have t squared. 2 divided by -1 is -2. So -2t. And then 8 divided by -1 is -8. Now we have that familiar simple trinomial, and we can do our product and sum. So we need two numbers that multiply to the -8 and then add up to the middle number of -2. So I know it's going to be a positive and a negative number, and right away I'm thinking -4 times 2, because if I multiply them I get -8, if I add them I get -2. And then we can just jump to our brackets, so t subtract 4 and then t add 2. So then our zeros from this bracket, it would be +4 because I'm taking the opposite sign, and from this bracket -2. Now this is time, and we're talking about when the balloon hits the ground. This negative time doesn't make sense because you can't have a negative time. So we just say inadmissible. It doesn't make sense. It doesn't work here. So that means it takes 4 seconds for the balloon to hit the ground. Therefore, the balloon hits the ground after 4 seconds. And there we are. In terms of the algebra skills, there isn't actually anything new here. I mean, we know how to find a y-intercept from standard form. We know how to do some substitution. And we know how to factor and find zeros. But now we're just tying it into the word problem. So let's try another one. Very similar. It's still the same types of questions. Let's see. A rock is thrown off a bridge. The height of the rock in meters can be represented by h equals -4t squared plus 36, where t represents the time in seconds. Okay, from what height was the rock initially thrown? There's that word initially, making us think of the y-intercept. And our y-intercept is the constant. Now, when I look at this equation, be careful. There's only 2 terms, so the last term might not necessarily be a constant. However, the 36, it's not attached to any variables, so it is our y-intercept. And our units are meters, so the initial height was 36 meters. So that means the bridge might be 36 meters tall at that point. Okay, after how many seconds does the rock hit the water surface? Water surface, those are the zeros. That's like when the ball landed. So if I were to do a mini sketch here, I'm not sure what this parabola might look like necessarily. It starts at 36 and maybe the parabola looks something like that. I drew it too far, but there. That's what we're looking for. That's when it hits the water, which means, once again, factor. I see the first term is negative. I need to do a GCF. They don't both have a variable in common. However, they are both divisible by 4. So I am going to divide out a -4 because the first term is negative, like I said before. And let's see if anything special happens. So when I divide the first term by -4, I'm just left with t squared. And when I do 36 divided by -4, we're left with -9. We're left with 2 terms. It's subtraction. And both terms are square rootable, which means we have a difference of squares. So remember, with the difference of squares, we square root the first term. So the square root of t squared is t. And then square root the 9 to get 3. So here's my GCF. I set up 2 brackets. The square root of t squared was t. The square root of 9 was 3. One bracket is addition, one bracket is subtraction. So then when I write my zeros, well, from the first bracket, it would be -3, and from the second bracket, it would be +3 because I'm taking that opposite sign. This one doesn't make sense, so it's gone, which means just 3 seconds for it to hit the water. Therefore, the rock hits the water after 3 seconds. And finally, how high was the rock after 2 seconds? So here, we're just doing a little substitution. I'm giving you time. Time is 2. So let's just go to our equation. -4. And then instead of t squared, we're going to write 2 squared. And then plus 36. Exponents always come first, like always. 2 squared is 4. Then we can do our multiplication. -4 times 4 is -16. And then we can finish this off. -16 plus 36 is 20. So therefore, after 2 seconds, the rock is 20 meters high. So all of these examples that we've done, they've been related to height and time, and you'll notice that the types of questions are very similar. Find the starting height, what's the height at a certain time, when does the object hit the ground or the water, that kind of thing. But we can also relate this, of course, to other scenarios that are represented by parabolas. So let's take a look at our last example. The profit equation for a new magazine is P equals -6x squared plus 36x minus 48, where P represents the profit in thousands of dollars and X is the number of magazines sold in thousands. How many magazines need to be sold to break even? So when the profit is 0. All right, looking at this, maybe it's not the most familiar type of thing. What special point are we looking at? So I'm going to make a little sketch here. Here's profit. And here is the number of magazines sold. Now the reason I'm letting profit be positive or negative, because you can make money or you can also lose money. Now for my sketch, I see that the a value, or the value in front of x squared, is negative. So my parabola is going to open down, and I know my y-intercept is -48. And the only reason I'm looking at these things is just for a little general idea of how to sketch this. So here's the y-intercept, and then just roughly, here's my parabola that's opening downwards. I want to know when the profit is 0. This is when the profit is 0. So look at what we're looking for. Once again, we're trying to find the zeros. So this is similar to when the rocket lands or when the rock hits the water. We're just trying to find those x-intercepts, which means let's factor. So when I look at my equation, -6x squared plus 36x minus 48, first of all, there is a common factor for sure. And remember, it's a trinomial. We want to make it simple so that we can actually factor this. So we're probably just going to be able to divide out that -6. And in fact, we can. So when I divide everything by the -6, well, -6 divided by -6 is 1, which was the goal. 36 divided by -6 is -6. And -48 divided by -6 is +8. So now we have that nice simple trinomial. So our product is going to be the +8, and our sum is going to be the -6. Because the product is positive, so both numbers have to multiply to +8, both numbers should be both positive or both negative. And both negative will give us the sum of -6. So -4 and -2 work. So then we're going to have x subtract 4, x subtract 2. So our zeros, when we flip those signs, are going to be positive 4 and positive 2. That does not mean that if you sell 2 magazines or 4 magazines, you're breaking even. And the reason is we have to read carefully here. X is the number of magazines sold in thousands. So we have to multiply both of these by 1,000 to actually get the number of magazines. So 4,000 magazines or 2,000 magazines would be our zeros. Therefore, if 2,000 or 4,000 magazines are sold, you will break even. Meaning you're not making money, but you're also not losing money. And that's it. So here's a little application lifeline as a little guide for you. The initial value, initial height, initial, like the starting height on the bridge, the building, whatever, is always the y-intercept. It always comes from standard form, and it is the c value. The zeros can be found using the factored form, like always. And you're just taking your numbers inside the bracket and changing the sign. The zeros represent when an object is on the ground, or they represent your break-even points for profit. And that's it. So we really haven't learned any new algebraic skills, but we're just applying them to different word problems. And the more practice you do, you'll notice that the questions get quite repetitive.